All right, let's get into it. Today, we're tackling a technology that promises something pretty incredible: unhackable code. We're talking about blockchain. So, let's start with the central problem here. In an age of non-stop cyber warfare, this question is, well, everything. It really boils down to a problem of trust. How do you trust data when you know some people on the network are actively trying to lie or manipulate information? The answer, as we're about to see, lies in a totally new kind of digital ledger. So, here's how we're going to break it all down. First, we'll get a handle on what a blockchain actually is. Then, we'll look at the 7 core properties that make it special. After that, we'll peek under the hood at the tech, walk through a transaction step by step, and finally, explore why this is such a big deal for the armed forces. So, first things first, what in the world is a blockchain? The easiest way to think about it is like a shared public record book that everyone can see. Okay, the formal definition is a shared, distributed, and tamper-resistant database. Now, every single one of those words is really, really important. So let's unpack what they actually mean. Okay, so what this all means is, first, it's a database that's shared among a whole group of people. It's not sitting on one central server somewhere. Second, and this is the absolute key, no single person or organization is in charge. New entries are only added when the majority of everyone in the group agrees they're legit. That's what we call consensus. And finally, once something is written into the ledger, it is permanent. It's set in stone. You can't change it, you can't delete it. Ever. Now, because of the way it's built, blockchain has some very specific and really powerful properties. Let's go over these 7 fundamental rules that define this technology. So yeah, there are 7 core properties that you really need to understand to get what makes this technology tick. All right, let's run through these. First, it's programmable, which means you can run automated smart contracts on it. Second, it's distributed, which means everybody on the network has their own complete copy of the ledger. Third, it's immutable. Like we said, once a record's in, it's irreversible. Fourth, it's secure, because every single record is individually encrypted. Fifth, it can be anonymous, hiding who the participants are. Sixth, it's unanimous. Everyone has to agree a record is valid before it gets added. And last, it's time-stamped, so every transaction is locked into a specific time and place in the sequence. You put all that together, and you get one seriously robust system. Okay, let's shift gears and pop the hood to see how this all actually works. The key concept you need to grasp here is something we can call a digital fingerprint. So the magic really begins with something called hashing. Imagine a special algorithm that can take any amount of data, a sentence, a whole book, whatever, and turn it into a unique code, a digital fingerprint. Now here's the cool part. If you change just one tiny thing in that original data, the fingerprint changes completely. This is what keeps the data inside the blocks secure. And these blocks are just like pages in our ledger, and they get linked together in a linear chain. The consensus mechanism is just the rule book for agreeing on new blocks, and the network nodes are simply the computers run by users and defenders that keep the whole thing running. Okay, enough with the theory. Let's make this concrete. How does a single transaction actually get recorded on the blockchain? Okay, picture this. A military unit, let's call it Unit A, needs to send a secure supply request to Unit B. So, step 1, that request gets created as a new block. Step 2, that block is immediately broadcast to every single computer, every node on the network. Step 3, all those nodes check the block to make sure it's legit and hasn't been messed with. Once they reach a consensus, we move to step 4. The block is permanently locked into the chain. And here's the genius part. Step 5. That newly updated chain is sent back out to everyone. This means a hacker can't secretly change the request later because their version of the chain wouldn't match everybody else's. It's self-policing. So this is all really cool tech, but why does it matter so much for the armed forces? Well, the applications here are profound, especially when it comes to securing our future systems. People are looking at blockchain for pretty much everything. We're talking about secure messaging systems that can't be shut down or censored, or transparent logistics, where a supply chain can't be secretly manipulated. But maybe the most critical use is building unhackable code for weapon systems. This lets you do constant integrity monitoring, which is a powerful way to spot those super sophisticated threats, the ones designed to hide inside a network for months or even years before they strike. This brings us to a really powerful idea called formal verification. Now, this isn't just about running some tests and hoping for the best. No, this is about using pure mathematics to prove that a system will work only as it was designed to in every single possible situation. It's pretty much the ultimate guarantee of security and reliability. Whew, okay, that was a lot. So let's do a real quick recap of the key things you should take away from all this. So the bottom line is this. A blockchain is a shared database where new records are added by group consensus, and once they're in, they can never be changed. Its power comes from properties like immutability and security. The technical secret sauce is hashing, that digital fingerprint that guarantees your data is safe. And for the military, this is a potential game changer for things like secure messaging and, crucially, monitoring the integrity of weapon systems against those sneaky, advanced threats. And that brings us to our final question to chew on. If this technology gives us actual mathematical proof that a system is behaving exactly as it should be, how does that fundamentally change the game when we're defending against attackers who specialize in being invisible? What does it mean for our security when we can finally, truly trust our code?